the title of my talk there is Beyond MLOps, and as Tristan mentioned, like we actually started working on Metaflow at Netflix starting 2017, so that was before the term MLOps even existed. I had never been a huge fan of the term MLOps. It has been always a bit ill-defined, so I'm very happy to talk about this beyond MLOps. So we were there before, we will be there after, life goes on. Now, overall, like as we all know, coming from maybe like kind of technology background, like we get like really excited about these different labels like MLOps and also different acronyms like LLMs and RAG and LoRa and everything that's going on, that has been going on last year as well. But also like all of us, I know that like many of us are here founders, many are VCs and so forth. So we know that at the end of the day, none of that matters, right? And the only thing that matters, of course, at the end of the day is like what we do with these technologies. That's kind of a no-brainer. So I actually like wanted to start with that. So this is an e-commerce store, 2014 era. Like many of you may remember that that's actually what the e-commerce used to look like. And like that's a very familiar layout. So on the left-hand side, you have filters, like you can choose the color, you can choose the material, you can choose the price, and then like you see the results there on the right-hand side. And like you can imagine how it works. So I choose color equals red, and the price is less than $5,000. And then like for those of you who are like more on the technical side, you can imagine like what happens on the backend side. The query goes to the backend. There's maybe something like a SQL database, and like you construct a SQL query, select cow cheese, like where the color equals red and the price is less than $5,000 and so forth. And then we get the results, and then we can show the results here on the right. And now, if you think that like what has changed, like between, let's say, what was the situation 2004, what was the situation 94, what was the situation 84, it has been the same paradigm since 1970s. Like we have a database, and then we construct a query, and then the database returns the results. And the only difference like between the 1980s and like 2014 is that now we can show pictures. That's kind of the big deal with the web. I mean, like we have the pictures of the results set, so that's kind of amazing. And that was 2014. And actually, like now, if you go 10 years forward, so that's last year. I think that the kind of the same store looks the same today. You can say that there are some similarities, some differences. What's similar is that you actually do have fundamentally the same user interface. You do have the filters that now they are a little bit less prominent. They're at the top, but you can still like construct your query. You choose the color, you choose the price, and so forth. But now what's different is that the images are bigger. So that's the kind of the big innovation. Like in 1990s, they didn't have pictures. 2014 had little pictures, thumbnails, and 2023 we have a bigger pictures. So the world is advancing. So things are great. Now, although it may seem a bit superficial, I think that the kind of a deeper trend line, what's going on, is that all these systems that we build are becoming more human-centric, are becoming closer and closer to like actual normal human beings. And so it happens that SQL is not close to human beings. Relational database is not close to human beings. And like that's why having this like a beautiful point-and-click kind of a interface to construct SQL query is not exactly human-centric. Having emotionally evoking pictures is more human-centric. So now, if you keep going forward and project like where the world is going, like what kind of systems, what kind of experiences we will be building in factually 10 years' time. I put the date there to be 2026, mainly so that like there may be some VCs in the audience, and VCs always get anxious when I say that something's going to take 10 years. So let's pretend that it's going to happen faster. And the future is unevenly distributed. Some of this will happen faster. But so what will happen is that, like, yes, the pictures will be getting bigger. But actually, like, what's even more exciting than that is, and like what's really like, I think that the most exciting thing about like what happened post ChatGPT is that we have a new user interface paradigm. I mean, whatever Sam Altman tells you, I mean, it's not about the AGI. AGI is not going to happen. But what's really, really cool is that we have a new user interface. And the new user interface is the natural language interface that we can do now for the first time ever, which is a big deal. Like we are finally free from that like a SQL kind of a paradigm, and like we can actually create these very human-centric experiences, which is that I can go to this store, like you can imagine an e-commerce store, where you say that, no, actually, like this is not what I want. Like, can I see a pink sofa? And now in this e-commerce store, like then we can show you a pink sofa. Or like maybe you say that, well, actually, like, no. I mean, like I want the leather sofa, and like then you get the leather sofa. And you can imagine that like kind of we are starting to have a bits and pieces of technology so we can actually like build something like this. Now, beyond that, you could imagine an experience where somebody can take a photo of the living room. You take your phone and you snap a photo of the living room, you upload it to the system, and then it kind of superimposes the couches and the furniture like in your living room, right? And then like maybe you get like other stuff there. Maybe you have a lamp and you can point at the lamp. Pointing is a very human thing. You point at the lamp and say that, oh, by the way, what's that thing? Looks beautiful. And then like you get this information about the lamp, saying that, oh, I mean, it's like the bamboo lamp, and like you get the description and all the good stuff, right? So now, so let's say, and I can come back here like in like, I don't know, like a 5 years, couple of years, and then we can see if this stuff is happening. But I would say this stuff is happening. I mean, this is where the world is going. So now, like for all of us here, like who are founders, who are builders, who are maybe people like funding these efforts, like how do we build these things? They don't happen by itself. Somebody is going to build these things. Somebody is going to found the company who is going to build the new e-commerce experience. Somebody is going to found the company who provides the new insurance experience, the new climate tech company. I mean, everything. There is that like constant innovation happening. So what's going on behind the scenes? So now, like obviously there is that new user interface. We have this like a natural language-based interface. We have the LLM. Now, I think like a couple of things I want to say about that. Like that is not just a chat bot overlaid on top of a big picture. That has been the kind of the most obvious thing that many companies started doing last year. Like we kind of have this idea that we almost equate LLMs with the chatbots, something like ChatGPT. But of course, I mean, that is not the end game. I mean, that's kind of the, in some ways, the silly first approximation, like what we can do with LLMs. In this case, for instance, you don't want to have a chatbot that can talk about anything and everything in the world and hallucinate about religion and hallucinate about the politics and everything. So you want this thing to be the most knowledgeable salesperson about furniture, about couches, right? So like you want to have the same like experience that you would have in a showroom. Let's say like you went in person and like you don't talk about anything else, right? Then another interesting detail here is that, let's say we do this whole thing like with the camera phone and so forth. So there's this tiny detail that when you point at something, you actually have to understand what the person is pointing at. And so it happens that this is a non-trivial problem. And it has been actually, this question of object recognition has been like one of the key challenges in computer vision for decades. And actually this example is created using Meta's model called Segment Anything. And it's amazing that like we are starting to have these models that actually can do object recognition pretty well. So that's really awesome, but at the same time, that's a non-trivial problem. Here, this description is also auto-generated. And why I want to kind of highlight that, a couple of reasons. The reason number one is actually organizational. So going back to that question about the relational databases and like kind of how we have been building software for decades, it used to be so that the engineers built the database, the engineers like built the infrastructure, and then you had the other department at the company, maybe sales, maybe marketing, maybe designers, who then like understood the business and then like populated the database with the descriptions, and they understood actually the domain. The engineer might have not known anything about couches, they just built a database, right? Now what is changing with the LLMs is that like, let's say we use these LLMs to actually provide this user interface, the direct interface to the customer. Now that thing that the engineers, the data scientists, the ML developers, the AI developers built, they have to understand the domain. Because now this LLM actually, it echoes the company's brand, it echoes the company's like language and so forth. So like whatever, like let's say like you want to do instruction tuning and like you have an instruction set, whoever is responsible for that like really needs to make sure that that is actually the right thing that we want to do for the company. So there are interesting organizational implications going on here as well. The other big deal is that besides the kind of the product experience itself, I mean, everything is becoming more sophisticated. Let's say you have this business, you are not going to just market this business by doing banner ads, 2010 style, maybe you do TikTok ads. Well, I mean, you don't just do TikTok ads. You want to have influencers on TikTok, and maybe you want to have a different influencers depending who you are targeting. Maybe you choose the kind of the endorsement on the fly depending who's on the site. So you can have a very smart system about that. And of course, in this case, like also the images that you generate, it's not just like you put something in Midjourney or DALL-E and you get some image. But I mean, that is, of course, a key part of the whole product experience. You very carefully have to make sure that like you don't get random couches, but you get exactly the couches that you can be selling and so forth. So you need to develop that system well. And this is an important part that, of course, has gone overlooked last year, which is that with generative AI, there's the generative part that implies that we generate something. But of course, like once we get past this initial excitement that, oh my gosh, we can generate something, what we actually generate starts mattering. And if you consider a company like Netflix, and if you consider the recommendations, the school book example of a recommendation system is that like you try to guess, let's say, like what is the movie that you would like to watch next? And like are you in the mood for like whatever romantic comedy or action and so forth? But of course, factually, that is not what's happening. I mean, like think about it. So Netflix's business is not to guess what you want to watch next. Their business is, of course, to optimize the lifetime value of their customers. And they are embedding their business KPIs and incentives into these models. And the same thing is going on here. You don't just like generate some images of some couches, but you understand very well that like, okay, what are the couches with the highest margins? So, okay, given that optimization goal, kind of what kind of couches we should be showing in this case to this user. So this is the kind of like what the user would be seeing. But then behind the scenes, there's so much more that's going on. So all sophisticated companies these days, also they have everything on the back office side, kind of the bottom of the iceberg, highly optimized. Again, I mean, stuff that like happens at Netflix. You see the recommendations, but there are actually like hundreds of ML AI projects happening behind the scenes. And the same thing with many other companies we work with. So you can, of course, like forecast the inventory. You can optimize the logistics. The world is a complex place. Are you going to create these couches on demand? Is it going to happen in China? Is it going to happen in the United States? You can optimize that. Now, when you are doing the marketing, you want to spend the marketing dollars really well. I mean, do you understand the causal relationship between the endorsements and then the purchase decisions? You can have a model for that, right? So the big picture that is emerging here is that in the future, like we have these ML and AI components everywhere in our business, both like very much powering the product experience by itself. If you consider something like TikTok, it's really like only AI, ML driven. The whole company is about ML and AI. That's how the whole engagement cycle works, for better or worse. And the same thing on the backend side. So like in this hypothetical example, we have 10 different systems, right? And now, like, let's say you are the VP of engineer or like VP of data scientist, VP of data science, and like somebody, the founder comes to you and says that, okay, by the way, like we have to build these systems. I mean, you probably are kind of sweating cold sweat that, oh my gosh, I mean, like each one of these boxes is an R&D project by itself, not easy at all. And this was kind of like roughly the situation that we were facing back in the day already at Netflix, like a lot of appetite, apply ML and AI everywhere. There's even the question that, is there anything in common? Why do we even put these boxes on the same slide? I mean, like you have a computer vision and you have an inventory forecast and you have LLMs, and in some sense, I mean, there's nothing in common, right? Well, I mean, another point of view is that if you really start thinking from the bottom up, there are some commonalities, like for instance, everybody needs data, right? So the data comes in different shapes and sizes. Well, very different data go into a computer vision model than go into an inventory forecast, but data it is. The other thing that you always need compute. Again, training and like a simple forecasting model using, let's say, scikit-learn or something like that is very different than, let's say, training an LLM, like orders and orders of magnitude of difference, but you need compute of different kinds. Then, again, I mean, in contrast to what people might want you to believe, these systems are not going to build themselves. It's not going to be Devin like building the system for you. It's going to be all of us building these systems, which means that we have many software components that need to be interacting, that like where we actually have to compose these systems, and we have to orchestrate this whole architecture, right? So we need to kind of think about like, how do we put this system even together, right? And then like the other realization is that even if you don't believe that it will be humans building these systems in the future, I think it's kind of fair to say that the world is not going to be a static place. Things change, data changes. You have to iterate. You never build a system like this once, but it's a continuous operation, right? So you have to keep iterating, and that's why you want to keep track of different versions, different model versions, A/B testing, all that stuff. It's absolutely necessary. Now, also, like what is really necessary is the realization that these ML and AI systems are not islands. They don't only live in a notebook. They don't only live in your favorite data science environment, but they have to be connected to your web services, to your data lakes, to your business processes, to your ERPs, to your CRMs. So like there are many, many different ways how you can deploy these things. And then at the top of the stack, there's the question that, okay, what are even the models that we want to be building? And the reason like why these are like kind of the foundational questions are in this order is that there's this picture that we have been sharing many times over the years. People seem to like it, where like you have these kind of two different personas on the kind of the purple side. You have these data scientists, ML engineers, AI engineers, and like oftentimes it is the case that these people are most interested in things at the top of the stack. And like it's very evident that over the last year, there's been a lot of talk about the different models. People get very excited. Just like was it yesterday when Databricks released their new foundation model, people get super excited about the new foundation model that comes out. Also, people are quite excited that, okay, how do we actually use these models? Like how many tokens we can get per second, and like how do we actually like get integrated to real-time data streams and so forth. And of course, like tracking experiments and so forth. But then like for most ML engineers and data scientists, the fact that you have to store data in a durable manner and get it fast, I mean, that's something that should just work. And the same thing with compute. If I'm a data scientist, if I'm an ML engineer, like, and let's say I want to fine-tune my model, or like I want to train my whatever XGBoost, I just want to have a system where I can say that like make it happen. And I don't really care about Kubernetes. I don't care about the cost of doing this on AWS, none of that stuff. So it should just happen. But then like we do have the yellow side of the picture, which is really, really important. Again, I mean, these systems are not going to run themselves. They're not going to build themselves. And you have the engineers, the poor guys who are carrying the pager day and night to kind of keep the data warehouses, to keep the data pipelines, to keep the compute systems up and running. And all these systems now like require the two sides. And I guess that's a bit of a difference, again, like compared to the web store, e-commerce store of maybe 2014 or something, where we kind of only had the yellow side. And like in some ways, life was simple. Like we need someone to keep up the web server and the database and stuff like that. And we didn't have the other side. But now I think increasingly like we kind of have both sides, right? And I don't want to spend too much time like just talking about Metaflow here. Plenty of information online. So suffice to say that because like we were facing this situation already before at Netflix, now many other companies have faced the same situation, that you always have to answer these foundational questions. Of course, again, I mean, kind of coming from the angle that it is people building these systems. It's not like co-pilots building these systems altogether. So having a simple interface, how you can access data, how you can do compute, you can just say that, okay, at Kubernetes, I need 64 gigabytes of RAM or like whatever it might be. It's very convenient. So that's what Metaflow does. You can check it out. And like, well, many companies have found it quite useful. So we are happy to add your logo on the slide as well, right? But now, like coming back to this question that, okay, I mean, let's say that this is the future. We want to be building these systems. So what does it actually entail? So I wanted to kind of highlight a couple of trends. Well, I wanted to get the most obvious one, like kind of off the table first. So there are like LLMs. I'm just quickly touching that question. But then there are like 4 other big things that I wanted to highlight, because I think LLMs, of course, have got outsized amount of attention, especially last year. But there are like many other things that have been actually going on. But I mean, maybe haven't got so much attention. Well, multimodal, obviously. But let's look into these. So starting with the LLMs. So, well, first, I don't want to bore you by saying the same things that like so many people have said already about LLMs. I just like wanted to highlight this one dimension that I think is interesting. So now, if you think that like you are the founder, you are the whatever CEO or product manager at the company building one of these AI-powered experiences, there's this interesting x-axis, where on the x-axis, like on the one side, you have the amount of effort that you are willing to put into building this system, and then on the other side, like you have kind of really that like kind of you can put little amount of effort or you can put a lot of effort, right? And now the amazing thing about something like ChatGPT is that you can get started with practically no effort. So you can go to the kind of the very bottom left corner, and you can build something basically with no effort at all. And now the main downside of doing that is that what you are doing is exactly the same thing that everybody else could be doing. And of course, last year and like over the past, I don't know, 16 months, we have been so dazed about this like a new technology that like just like a building something that just hits the OpenAI API has been kind of sufficient. It's different enough. But imagine a world, and I can guarantee that this world will be actually happening quite soon, where like the customers and like where engineers and everybody, they have heard this thing so many times that just saying that we do something AI, it's not sufficient. But then the question becomes that how do you differentiate, right? And of course, like today, the easiest way to build differentiated experiences, let's think about that like the kind of the query interface in that like a couch example, is that you can do prompt engineering. And now the interesting thing about the prompt engineering is that you can kind of decide to do as little of it as you want. So you can just hit the OpenAI API, you don't have to do anything, you kind of get something. Or then like kind of when the customer expectations start increasing and like just having a yet another half hallucinating AI chatbot is not sufficient anymore, then you can kind of like start thinking that like, wait a minute, we have to do something more, and like you do your RAG thing and like you do everything else, and like you start putting kind of more kind of like a sweat and tears on like getting the system behave a bit better, right? But the nice thing about the prompt engineering is that like on the y-axis where we have the computational cost, I mean, it basically doesn't cost much anything, assuming that somebody else keeps the system running for you, which is kind of this case today. And like many companies have been in this situation, they do some prompt engineering, some amount of effort, and then you hit one of these APIs and kind of easy to get started. And that has been why so many people have been doing this, because if it had been hard, like not many people would be even excited. But now on the differentiation aspect, I think like we are increasingly getting to the point that companies are starting to realize that, wait a minute, I mean, we can't just like do the same thing as the kind of 20 other YC startups 3 months ago. We have to do something more. And they are like happy medium solutions here. So I mean, just to highlight one thing, not that this would be kind of the only thing in town, but I mean, last week there was the NVIDIA GTC. Jensen went on stage and announced that like NVIDIA now provides these NIM microservices, pre-packaging many of the open source foundation models as basically Docker containers that you can run in your own environment. So instead of just hitting these existing APIs, you can kind of bring the models to your side. But the beautiful thing is that like you don't have to do all the same optimization that the guys at NVIDIA have been doing, like using TensorRT and VLLM and so forth, but it's kind of like all like nicely packaged. And you get a couple of benefits with this. You don't have to worry about the rate limits. The cost may be lower. Like you have more control. Like you don't have to send the data to OpenAI. Like you know the versions of the models you are using. So a little bit more effort, kind of some amount of more computational cost, but I mean nothing crazy. And that takes you like a bit more like towards the differentiated category. And now, of course, like at the very extreme, like you have the option that you can do as much by yourself as you want. So for instance, like I guess there was the quote yesterday that Databricks spent $10 million like training their own foundation model. And that's kind of maybe extreme. So you don't want to do that maybe, but I mean, you want to maybe fine tune your model. I mean, definitely more effort, way more effort than like just hitting the APIs. But again, I mean, gets you way more like to the differentiated side of things, which is fun. And now, like, again, going back to the theme of beyond MLOps. So they're like a different like kind of amount of value add that the system like Metaflow can provide. Obviously, if you are just hitting the black box APIs, honestly, you are not even doing any data science. You are not doing any ML. You're just calling an API. So I mean, kind of, there's some amount that maybe what Metaflow can do to help, but I mean, limited amount. And our focus has been especially like thinking that where the world will be going, like as companies like want to move beyond, they want to move kind of like to the right-hand side. And then, of course, like especially this question of compute becomes very acute. So like if you think in terms of the stack, like what has been the focus, so there has been much focus about, on the one hand, like compute, how do we get access to GPUs, how do we can actually like even do the fine tuning, I mean, it's kind of like still like a bit like a pain in the back. And then like once we get the model, like how do we actually deploy that custom model in some kind of an inference environment, which has been like a kind of a focus of much attention. I think that situation is much improving, but I mean, has been still quite hard today. So I don't want to spend too much time on these topics, but if these topics happen to be of interest, if you are interested in moving kind of like to the right-hand side on that spectrum, like we have a couple of blog posts, like for instance, now you can use Metaflow with things like Ray or DeepSpeed or PyTorch, and like let's say you can even do distributed training. And why this is relevant. I mean, it's not because necessarily like you want to become the next OpenAI, but let's say you want to lower cost by having smaller GPUs, and then you have to distribute your fine-tuning across multiple GPUs. So that is now a bit easier than what it used to be. Also, like we can help you to get access to different GPU resources across all the clouds and all that good stuff. So that's the kind of the compute is a big trend line that is happening, changing the landscape, right? And on the deployment side, again, I mean, that's a very fast-moving field. I guess the kind of the main thing that I want to say about that, besides all the technical stuff that's happening, is that it's really important to recognize that there are many ways how you can apply ML and AI in your systems. It's not always that you have to find like the fastest inference endpoint. So for instance, like if you think about the description LLM that I had in the picture, that would be, let's say you want to crunch through the database of like 100,000 products and produce the descriptions for them. That's more like a batch process. You do it every now and then. So again, I mean, like a very different deployment pattern. So again, I mean, there's a nice blog article about like many ways to deploy models that we published a month back or so. So okay, let's move forward. So multimodal. So everybody has seen like all kind of like really awesome demos about videos, images, so forth. So what does that mean? Well, in terms of this picture here, these axes, I guess the kind of really the main thing to note is that everything just becomes harder technically with multimodal. So if LLMs were hard enough, like to fine-tune the pre-train and so forth, I mean, everything just like goes through the roof with multimodal. So like the amount of compute that you would need is just like kind of a way higher, especially with video and like coming from Netflix, like we had a bunch of media, it's just harder, right? And like the reason it is harder is that obviously there's just much more data. So it's one thing to kind of take all the written language, all the Wikipedia. If you think about it, like all the Wikipedia, it's like some tens of gigs compressed. I mean, it's really not that big. But then like you take even like a decent amount of video and like kind of that goes like through the roof, like 100,000x more. And on that note, I mean, of course, like all the compute concerns still apply, all the deployment concerns still apply. And now you kind of have this like I/O concern, like how do you actually get the data moving fast enough? And like we have been kind of developing solutions for the I/O path, so you can run your GPUs red hot, so you can go to the blog, like check out this like a fast data. We have a custom S3 client. You can pull 50 gigabits per second from S3 and so forth. So you can then like produce dancing pandas and corgis playing guitar. So yeah, so that's happening. I mean, definitely something that like would require much more effort. But I mean, those companies who are engaging in that journey, you can of course like get so much more done on the differentiation front. Well, now talking about the other trends besides the kind of the Gen AI stuff, this is one of my favorite topics. I think goes very much underappreciated. So let's talk about the hybrid models. So let's start with this kind of standard image that like how do you do like a classic ML, traditional ML, predictive ML, the stuff that we have been doing for decades. So how it works is that you have some kind of structured data, let's say in a relational database. You have, let's say, your product database, like you have some columns like about what you know about your products. And let's say that's in Snowflake, Postgres, whatever. You load the data. You can put it in, let's say, in a pandas data frame. And then like you have a bunch of feature encoders. And then like kind of you put the data frame inside through the feature encoders and you get the matrix out, right? Or maybe a tensor out. You get the bunch of numbers. And then you put that bunch of numbers, the matrix like through like XGBoost or scikit-learn or something, and you fit the model, right? And like then you have a kind of a predictive model, and then you can of course like test and evaluate all that good stuff. And now this is the way if you, let's say, wanted to build the inventory forecasting system, or if you wanted to build the system to optimize marketing spend. I mean, this would be roughly the pattern, right? And this is what companies have been doing for ages. Now, the interesting thing here is that, of course, in the business point of view, if you are the data scientist, what you are supposed to do is that at the end of the day, you are supposed to increase the accuracy of the model. You are supposed to increase the quality of these models so that they can help the business more and more. And as many of us have learned over the years, the best way to improve the accuracy and the quality of these models, I mean, there's some amount that you can do with hyperparameter optimization, some amount that you can do by like going through different model families. But ultimately, the best thing to do is to have more data, like have better quality data go into the models, have maybe better quality features. I mean, that's of course like kind of ultimately like how how these things improve. And now the interesting thing is that like getting high quality data, kind of adding columns to that table hasn't been that easy. So for like many, kind of a couple of decades that I've been doing this, always when building a system like this, somebody comes to you and says that, oh yeah, like we could improve the model if only like we could use more data, and then somebody comes up with an idea that, oh, we have all those customer support tickets, or we have, who knows, like all the Slack discussions, all the emails, and imagine like if we could include the customer support tickets in the churn model, so if the customer has been complaining, and depending what they complain, that actually informs how likely they are to churn. And then always before it has been the case that then like your data scientist colleagues, they shake their heads that, yeah, but the data is so messy, it's kind of unstructured data, hard to use, and so forth. So I mean, like, yeah, it would take too much effort, not gonna do it, right? Now, of course, that picture is really, really changing, and this is super exciting because now, thanks to let's say large language models, suddenly all the unstructured data, all that like a natural language material that you have, everybody has it, right? So like that you have available at your company, it actually becomes somewhat easily available to improve all the existing models that you have. So all those models that you use to predict house prices or like do the churn or whatever, now you can take the other data assets that you have, you can take the text, like put it through the LLM, get some embeddings, concatenate the embeddings with your feature matrix, and then like run it through the same predictor and kind of in some cases like get better results. And suddenly you have way more data available for your models. And now you may ask that, okay, well, embeddings have been available for ages. So I mean, embeddings are not new, right? So what has changed? Well, I mean, what has changed with LLMs mainly is that usually like this unstructured data, it's kind of messy. Oftentimes the messages are short. So if you just like have a bit simpler model to produce the embeddings, the quality hasn't been so high. But now LLMs, because there's the L, the large language model, there's so much more context about the language and everything that there's the case to be made that the embeddings are much higher quality than before. That actually, like, even though you may have tried this in the past, there's a good chance that now this actually works and it hasn't worked in the past, which is amazing. So now, for instance, like if you consider, let's say, this like a personalized discovery use case where like you really want to understand that, okay, what kind of furniture we should recommend to this person? Like, well, I mean, in the past, we could have taken into account like structured features, like what kind of like browsing history they have, what kind of products they have viewed in the past, like what is their demographics and stuff like that. Now you can also like take a look at all this other stuff they are doing, like reviews they have written, like maybe their social media activity, all that crazy stuff. You put it through the LLM, you get the embeddings, and like you may get better results. And the exciting thing and like where the future is going is that it doesn't even stop there. So now you have the predictive model that, let's say, would tell you what is the propensity of this person buying a pink couch. And now imagine the salesperson. I mean, imagine a human salesperson at the showroom. What the most experienced salespeople do is that they can look at you and they look at what you look like, what kind of clothes you wear, and they have their kind of internal propensity model that, wait a minute, I mean, I should probably recommend this thing to the person. And now with our LLMs, let's say we had this propensity model, we can actually take the output of that model and provide it as an input to the LLM. And now the LLM knows that, oh, actually, like this person is most likely to like leather sofa, and then like they can have the dialogue accordingly. So again, I mean, this is a bit futuristic, but I mean, I think that this is where the world is going. And the same thing, of course, like we can like use this for like the generative AI use cases. We can connect the models to other models and so forth. So super exciting. Now, the biggest downside and like the biggest reason why this is not happening today, like why it's going to take a while, is that like it's kind of hard. You need all the layers of the stack. You need the compute to produce the embeddings. You have to have like pretty sophisticated data flows to like stitch together the system. You need to orchestrate all these parts, and like many more pieces to version and so forth. So there's actually another blog post like we published about a year ago. There's this like a nice architecture diagram giving this high-level idea where you're gonna have like some systems like where you take an open source large language model, you produce embeddings, the embeddings go to the recommendation system, then you have another pipeline producing images. And I think that that's roughly starting to be the kind of the architectural pattern of like many of these sophisticated like ML AI systems. You have multiple pieces, multiple models all working together. And like that's kind of the future. But now, one thing that I like before like we run out of time, definitely want to highlight, because I think that this is also something that goes underappreciated because of the AI that's happening, is that the classic, the traditional ML has been actually going super strong, like behind the scenes. I mean, even if we put all the AI aside, what's one of the best part of like kind of what I get to do on a day-to-day basis is that I kind of hear about all kinds of companies. And these actually, you can go to our like YouTube channel, Outerbounds YouTube channel, you find these videos. You can hear from these companies firsthand. I mean, there are many examples there. How people do all kinds of things these days, like with machine learning, and I couldn't even imagine. Like there's equilibrium energy, like they're optimizing the electricity grid here. I believe in Texas, like based on because the kind of with the renewables, the kind of the amount of energy goes up and down. You can predict that. You can make money. You can load battery stuff. Or like we have many climate tech companies optimizing like a resource usage, the land usage, the kind of a consumption, like using machine learning models, really fancy stuff. And of course, like a pharma, healthcare, biotech, or like something like kind of you can build new kind of insurance companies. So it's absolutely like amazing, like what people are doing, right? Or like kind of a ramp, like a super fancy fintech, like doing fraud detection and so forth. Now, this is an article that Netflix published a few weeks ago. I think like the main thing that I want to kind of show here is that the one trend line about these machine learning systems, and again, like going beyond MLOps, is that the level of sophistication in many of these systems is really kind of going through the roof. So many of you may have been involved in systems where you maybe have your data science team and they had one ML pipeline scheduled by Airflow, and it produced some predictions that they wrote back to Snowflake, and that's all cool and fine. But then, like for instance, this example like gives a high-level schematic of the system that Netflix uses to decide how they spend $16 billion every year to produce content. And here, like every one of those boxes is actually a workflow of its own. So this is kind of like a Metaflow. And you have an ETL, you have different models, like everything like working in concert, like all the systems feeding each other to understand what kind of stuff people would like to watch around the world. And now you might ask that like, why on earth? I mean, like kind of it has to be so complicated, like kind of those guys at Netflix, I mean, they might be really stupid. Well, it turns out that the world is a complex place. It's very hard to have a overly simplistic answers. And there is the tendency that like if you have the proper business incentives to do a good job, that like you just keep adding more and more nuances to your model families. And it just like means that like these systems are like becoming more and more complex, and you need infrastructure to support that. One thing that I wanted to say before I end, kind of echoing actually the previous talk by Tekton here, is that there is this very interesting development happening kind of a bit like kind of a undercover about the unbundled data stack. This is also a picture from the Netflix blog post. You may know that Iceberg is actually a table format, like open source one, came out of Netflix as well. And like what, let's say, Netflix is doing is that they have a massive scale data lake organized as Iceberg tables, kind of the same stuff as the Delta Lake in the previous talk. And then they are like able to kind of get this data to the kind of the very data science ML systems that I showed in the previous slide by going super fast to their data lake, like resolving the Iceberg tables, like putting it directly to the process memory using Arrow and so forth. And again, this is the stuff that has been kind of maturing kind of there like under the hood for the longest time. Like Arrow has existed, Iceberg has existed, but it just takes time for things to mature. And now we are finally starting to get to the point that this stack is starting to work, which opens up many kind of like new possibilities how we architect, and also like how kind of people get to experience these systems. So that's super cool. But again, I mean, like you kind of need all the kind of parts of the stack to build systems like this, especially the orchestration like is really important, like as the kind of systems grow in complexity. So anyway, so I won't be going through like all these points here, but like what's really exciting is that now we have like a whole new family of models allow us to build new kind of user interfaces that are driven by these very human ways of communicating through natural language, through images, so forth. Also, what these new Gen AI models allow us to do is that we can suddenly start using all unstructured data to lift all the models. With that, also like there's the huge like kind of a trend line with the demand for compute skyrocketing, and also the compute landscape getting more fragmented. So gone are the days like when we only had x86 CPUs, now we have GPUs, we have AWS training, we have AMD, we have Cerebras. So much more stuff happening on the compute side. And then also like thanks to the heightened interest, like an event regulation to AI, understanding the metadata, the lineage, that like what goes into the models becomes kind of more important than ever. So everybody has been always talking about the data lineage and like metadata and so forth, but hasn't been like maybe a strong business incentive to make it happen, and now they're starting to be that. So Anyway, long story short, like how you build these systems, you need a solid foundation. Take a look at Metaflow, take a look at Outerbounds, so we can help with that. And then like go absolutely crazy, go creative, like building things that go beyond the chatbots, the kind of the most obvious thing. So thank you.